Hi there, Missy at missygoesboating.com. Well, today we are out for our annual maintenance. We're out for about a week and a bit. Our first job, of course, is take the props off, which you'll notice they are missing. I have a video of stem to stern taking them off, and I've driven them out to Osborne. We're going to meet up with Jody, and he's going to explain what he did. There's a little dent, probably not my dent. There was a little dent in the props, so we're going to get those fixed and then put back on. While we're out of the water, of course, we're changing all of our zincs, doing a little touch-up painting, and she'll be already go back in the water for winter boating. Stay tuned. I keep my boat in the mighty Fraser River. My marina is near the estuary where fresh water and salt water from the Pacific Ocean mix, creating brackish water. It has a huge upside because my boat engines get a regular freshwater flush, and because she sits in fresh water the majority of the time, there are no barnacles and the bottom stays much cleaner. There's not a lot of growth in the fresh water, and the current really runs at the dock, so nothing really has a chance to latch on. However, there's a huge downside because there are so many logs in the river. Even at the dock, quite often we will hear them hitting the hull. While traveling on the river, we always have everyone on deck watching, but sometimes you just don't see them. The last log that hit us, we didn't see from the bow, and it didn't pop up at the stern. Just a big thunk on the midship and two smaller thunks as it passed by, obviously hitting the props somewhere in between. Here's a bit of local knowledge. At the entrance to the Fraser River, just off the UBC Bellboy, is a saltwater wedge where the fresh and saltwater meet. The river's fresh water flows over the denser saltwater, creating a visibly distinct line where the two meet, but also creating a mixing zone which exists below the surface. This means that quite often logs will travel with the current far below the surface, and you really don't stand a chance, so it's best just to go slow. Now back to the boat. We met stem to stern at the dock, and they used a metal gizmo called a Propeller along with a hammer to remove both props. With the props off, I hopped into my sport utility Camaro and headed out to Osborne Propellers in Langley. All right, here I am today at Osborne Propellers out in Langley. I'm here with Jody. Jody and his brother Jason have owned the operation for how many years?
My dad bought it in 2005. We kind of took over about 2010. And then we were in North Vancouver for an awful long time.
That's where I took my first propellers, were North Vancouver.
Yeah. There were some challenges for us, just with the facilities and how old everything was. And, the cost of North Vancouver with taxes and stuff, it kind of made us look for options to do something for ourselves. So we decided, we knew this business park from previous business ventures. We liked the location because it's kind of, easily accessible even from downtown. I mean, traffic's bad now, but so about 7 years ago, we decided to make the move out here, and it's been fantastic. I mean, the majority of our work is commercial in terms of like sales volume, and all of that stuff comes by truck. Doesn't matter if it's at a shipyard or not at a shipyard. That was just coming on a truck. So there's been an effect on some of our market segment, like the individual boaters now have a little bit further to drive, but
it wasn't a terrible drop. It was a nice day today.
It's a nice day today. I'm gonna be honest, Fridays in the summer, a little bit tricky. I know every back road through Langley to get here, but it's been a really good move for us.
That's good.
Right?
That's good. Now, tell me a little bit about when a prop arrives.
Yeah.
What is the process? What are you looking at? And you can look at my props when I brought them in. They had some pink on them, and they were a little dented.
Okay, so first off, let's go over the type of stuff that we do, because a lot of people don't know that we do everything. Perfect. So, we start with, we repair almost every propeller that comes through our door, with the exception of aluminum outboards. We don't do that work here. We're not allowed. WCB came in and said, if you're going to work on aluminum, we need you to have an explosion-proof dust handling system. That's $250,000. So right there, we're like, we can't afford to do this. We send aluminum out to other people to work on for us.
Perfect. Okay.
So, but we work on really small and really big, and we do everything here. So we're a full service company. So we do repair, we do design and engineering, we design our own propellers. We work with foundries and propeller companies all over the world to produce stuff for us. Yeah. And we also work as distributors or dealers for other brands. So I'm a distributor for Veeam in Canada, CJR Propulsion, Michigan Wheel, ZF Propulsion. And then I work with other like bigger companies that do, really large commercial stuff. So we cover everything. Wow. So we're kind of unique in that regard, is that we can fix your little outboard and we can fix the big ferry stuff as well. So BC Ferries is one of our big customers, Seaspan, most of the towboat operators and ferry operators in Western Canada, and then a lot of the fishermen in Eastern Canada as well. So we do everything.
Everything.
Yeah.
Okay, when I brought my prop in, I really didn't know the process or what I was looking for, and Jody was super helpful. So if you're a first-time person to Osborne and I brought in my broken prop, what are you going to look for?
First thing we're going to look for is the material something that we can fix? One of the issues that we see a lot, in particular with bronze propellers, is that they're subject to corrosion from electrolysis or electrolysis damage. So we'll see discoloration of the material. Typically, it looks a little bit pink. And, a lot of people don't understand what that means, right? So for the most part, you see a little bit of pink on your propeller. It's not a big deal. The big deals happen when you take something soft, plastic, right? And this isn't good because it's sitting on paper, but this one, when they're fine, they typically have a ring to them, right? If you tap on a bronze propeller and it sounds like you're hitting something wood, that's a problem, because that means that most of the zinc in that alloy has leached out through electrolysis and all that remains is copper. Copper has zero strength in terms of what you can do. So if you hit something, you're going to do significantly more damage, probably lose huge sections. And from a repairability standpoint, it's not going to respond well to twists. And, all that we do here when we repair propellers is twisting, hammering, heating, right? So none of those really respond really well to a brittle material. And that's what happens when there's significant electrolysis damage. So that's on bronze alloys, like manganese bronze in particular. This propeller that's sitting right here, this came in from a vendor. They sent it by courier. This is how we get most of our stuff here. Arrives by courier, has the information of the customer, the boat, and we're gonna do an inspection on this and figure out what's wrong with it. I can see it's got some dents. So we're gonna scan it, we're gonna tune that up, we're gonna refinish it and balance it. And then it's good to go again. So we repair everything here to an ISO standard for propeller construction, but it's the only reference that we have for repair. So that defines, according to whatever classification you use, Class S, which would be the finest, really hard to achieve, typically only by CNC. Class 1, very fine tuning, right? Something that we can do here by hand. Class 2, which is typically workboat stuff. Again, the tolerances get wider and wider. The sections that we look at get bigger and bigger, but they're slow, like the workboat stuff and tugs, slower moving, right? So they're less susceptible to vibration and issues because of how finely tuned the pitch is. But the smaller it is, the faster it works, the finer that tuning needs to be. And that our computer inspection equipment really goes a long way in determining where that gets put on and how fine that's done. And it helps us match stuff up really well.
All right, my second question is, because we hit a log in the river and immediately noticed vibration at lower RPM, so 800 to 1100 RPM. When we did a higher RPM, there wasn't as much vibration. And by vibration, I mean, you could feel it on your feet on the floor and you could hold the railings and notice the vibration. So can you talk about the dangers of running with a prop that needs to be repaired?
Vibration kills all sorts of stuff, so vibration's bad for bearings and seals and gears, right? The more vibration you have and the longer you run it, the more damage you could do throughout the system. So you can also damage your shaft more. Like everything reaches a stress point, a breaking point. So the reason why at certain RPMs you're feeling more vibration, right? And then less, there's every turning component has a natural vibration frequency. So your shaft material, for example, will have this natural frequency, like a sine wave, right? So as it's turning at a certain RPM, there will be an RPM where that material will naturally want to shake, right? So the spacing of the bearings on your boat are done to counteract that certain vibration harmonic frequency, right? It's called harmonic frequency. So this is Osborne Propellers, and this is kind of the start of our process here when stuff comes in for repair. So we've received several sets of damaged propellers, and the first thing we're going to do is kind of look at them to view the extent of the damage, whether or not it's repairable, and then we're going to enter it into our system. So we
have to ask, is this repairable?
Oh yeah, this is repairable.
I'm going to put some close-up pictures because this is quite crazy.
Yeah, no, this is due to the cost of these. That repair would be something we would recommend. Primarily, number one, cost. Number two, lead time to get it back. And with vessels that do work, like charter or working vessels, they can't afford to be down for very long, right? And the lead time to get another set of these, because these aren't a working vessel, but they come from Italy. So this is going to be 5 months, 6 months to get another set made. So yeah, there's some incentive for us to repair these. So we have records, like this is something that was done by us in the past. So we have a previous record. And
do you know how this damage happened?
No, but I can.
Wait, is this a hit or is this wear and tear?
Oh no, this is somebody hit Canada. They didn't hit a log. This is after we do all of our inspection stuff, determine whether or not we can fix it. We have to kind of figure out the extent of the damage. So we have several computerized measuring machines here that help us look at propellers. So this is one that's sort of mounted to a repair bench. And this enables us to look at the propeller, scan the pitch, and it'll tell us where, if it's out anywhere, where it is. So this one, we've gone through that initial scan, and you can see on the screen there, it's indicating a number of areas where stuff isn't correct. So this computerized inspection is really important in determining how badly damaged is the propeller, and then we can now set the pitch what it's supposed to be. We can correct it everywhere, and then we can use this template from this left-handed propeller. We can use exactly the same repair template for the right-handed propeller that's over there. So now we can match them up completely, every part of it. So this is a really, really valuable tool for us. And we do everything from like the smallest outboards like this up to, 120, 130 inch propellers. Uses the same technology. Not on this machine though. And then this, when we find something that's out on here, like you can see on the screen, we use these hydraulic cylinders to come in, and we'll make slight adjustments to the angles of the blades at the different radius points. And that's going to bring the pitch back into alignment. We can use it to adjust the height of the blades, a whole bunch of stuff. So really, really useful tool. And it takes an awful lot of the traditional methods out. And these are the traditional methods of adjusting pitch and, straightening stuff. We still use this quite a bit, but this makes that quite a bit easier. Okay, so what we're looking at on this screen, this is sort of the overview of how that pitch is distributed across the propeller. So we're looking for a target here of 26.5. That's our goal, right? We've set that target. This is that target box displayed here, and it's red, which indicates that we're not meeting that 26.5 pitch target at the propeller level. And then what these boxes indicate is down here, this is the 50 radius, 70, 90, and 95. So that's like the middle of the blade in terms of distance from the hub, and this is all the way out to the tip. So there's a pitch distribution that we're going to assign here to get it to 26.5. And in this instance, that's called a straight pitch. So everything's the same across. This view shows us exactly where on each section the damage is. So we know where we have to make adjustments. This shows us how the heights are affected by that damage at the different radius points. So you can see as we get out to the tip here, there's some inconsistencies of the blade tracking, basically the height. And then this last thing is, here's the local pitch across the propeller blade, right? And that shows that the 50 radius, the damage is mostly the middle and the trailing edge. And that distribution sort of changes with the design. So those are the targets for where we want to get the pitch into. So that shows us where the adjustments need to be made. And we can define this further and keep it from job to job. So it's really effective in matching stuff up really well. Yes. So this one, Nathaniel is just heating up a blade on a really severely damaged propeller. So we use heat here to make that material way easier to move. Because if you don't, when you try to bend it or hammer on it, it can potentially crack. So some stuff we do cold, a lot of stuff we're going to do hot, particularly if there's a lot of deformation. So we know the temperature ranges to work the different types of materials, how hot to get it, how fast to get it hot, you know, what color it looks like when we're working the material. So yeah, there's a lot of experience that goes into being able to do that well. Really, really difficult, lots and lots of damage. But it's incredibly expensive. So this is one of those times where the cost of it kind of makes it repairable, even as a spare, right? Like we'll get that into a condition. It's never going to be a Class S propeller again, which is a Veeam, so it's a Class S fully machined, but it will be a spare propeller for them to use. They've already ordered another set. But if this happens again, they want to have a propeller that they can limp home on or use for the rest of the season or whatever. So that's one of those decisions on should we repair it or not repair it.
So these were my props before I brought them to Osborne, with a bit of pink corrosion and a couple of log dents. And these are the props after a spa day. Beautiful.
Difference between right hand or left hand. Looking at a set of propellers, right hand, this is the trailing edge, this is the leading edge. If I put the fingers of my right hand on the trailing edge and my thumb touches the hub, that's a right-handed propeller. So my left hand, fingers on the trailing edge, thumb touches the hub, that's a left-handed propeller, right? So they turn like this, right? So the right hand goes on starboard, the left hand goes on the port. Quick test to see if electrolysis has damaged the propellers is to just tap it with something. You hear that nice ring? So that means that, you know, generally everything's fine.
All right, well, I've learned a lot today, and I saw a lot of really beautiful props and some really broken props. And I think my funniest comment that you said is that one hit the earth.
No.
I love that.
That one hit, those ones hit Canada.
Oh, they hit Canada.
Yeah.
So ours is just a simple log strike. But there was a lot of vibration, and I'm really glad that we brought it in and we had it repaired. Next step, we're taking it back down to the boat today, and Stem to Stern is meeting us to put them back on. So I'll pick up with our sea trial, which is the next step. But Jody, thank you so much.
That's great to have you. Thank you for coming by.
I learned a lot today. Thank you.
Huh?
Stay tuned for the sea trial, and we'll see you on the water.
So in true Missy style, I was so excited about a boat ride, I completely forgot to shoot any video from the sea trial. Everything was fantastic. We took the boat up to 25 RPM and no vibration. Hallelujah. A big thank you to Stem to Stern and to Osborne Propellers. Another boat maintenance project is in the books. See you on the water.